Statistical consideration of design, the studying the variation in the characteristics of components or the elements, the group of apparently identical components or the element are considered. This entire group of apparently identical components are known as the population. So simply I can say the population is nothing but the collecting all the elements which we are going to study, and from that the data we are trying to draw some conclusion, and this is nothing but the population. So suppose if we have the hundreds of the shafts, okay, and the hundreds of the shafts have their diameters, different diameters. Suppose the first diameter is 39.32, the second diameter is 39.42, third one is the 39.52. So in this way the hundreds of shaft diameters we have collected. So this collection of the data is called as the population, okay, and from that the population we are trying to draw some conclusion, okay. And suppose sometimes it also happens that we have a lot of diameters of shafts available with this, and it is not possible to measure each and every shaft, okay, to draw the conclusion. So what we are going to do, at the time of the inspection we are trying to draw the random shafts, okay. Suppose from the one there are 1000 number of shafts are there, and in that the 1000 shaft we are trying to draw the 10 or the 20 shafts randomly, okay, and by taking that 20 shafts or the 10 shafts we are trying to draw the conclusion to take the appropriate action. So this is called as a sampling, okay, or we can say it is a sample. So next is the raw data. So raw data is nothing but the collection of the numbers which belongs to be observation of one or the more variables, okay. And the next, that is the frequency distribution. In statistical analysis, when a large number of observations of the random variable are made from the population or the sample, it is necessary to represent that data in a systematic manner, okay, before the analysis is done, okay. So that is, to analyze the data we need to systematically arrange that population, or we can say that the numbers or the variables that needs to be systematically arranged to draw the conclusion or for the analysis purpose. So most common method used to represent that data, it is the frequency distribution, okay. So the frequency distribution is nothing but it is the organized display of data that shows the number of observations that fall into the different classes, okay. So that is for the frequency class and the class intervals and the class widths, okay, which are enters in the frequency distribution that we are going to see in the next one, okay. So this class frequency, so what is meant by the class frequency? It is the plotted against the observations. So there are basically the two methods of representing the frequency distribution. The first one is the histogram and second one is the frequency polygon, okay. So that we are going to see, okay. So what is the class frequency? The number of observation belongs to each class is called as the class frequency, okay. And what is the class interval? The range which defines the class is called as a class interval. Now what is the class width? The difference between the limits is called as the class width. So that we are going to see, that is a frequency distribution. So what is the frequency distribution? Over here you can see, this is what a frequency distribution table, okay. So here the class width, histograms, the frequency polygon and the class frequencies are shown, okay. So this class frequency is plotted against the observation. So you can see the class frequency right over here, okay, that is 10, 20, 30. Over here the class frequencies are shown, okay, and here the shaft diameters, okay, or we can say the class width are shown, okay. So here the class width is the 5 and the class intervals are 39,925 to 39,930. So that is the first class interval, second class interval, third, fourth and fifth. So in this way there are the 5 class intervals are there, and with the width of 0.005 like widths.